This question says, are freshman psychology majors just as likely to change their major before they graduate compared to freshman business majors? So do you understand the question? We're saying, okay, who is more likely? You go to college and sometimes you change your major after a year or two. I did that. Many people do that. So who's more likely? Are psych majors or business majors? Who's more likely to change their major? Well, they did a study and they found that 55% of 640 freshman psych majors in a recent study changed their major before they graduated, and 55% of 680 freshman business majors changed their major. Looks like the same, doesn't it? I mean, those are exactly the same. But maybe that was just luck. That's what the calculator will tell us about. All right. So what kind of a test is this? Well, you can see that there's two percentages, huh? So we're going to choose the z-test for the difference between two population proportions. There's two percentages, two proportions. So that's our choice. Okay, so now we got to write HO and H1 and come back. Here's the notes, the Unit 4 notes. So we're doing two proportions. And go to the online calculator, two proportions. That makes sense. Hypothesis test, HO is going to be P1 equals P2. Remember, HO is always equals. And H1 is going to be P1, P2 as well, greater, less, or not equal. We'll come back here and go, oh, okay. So HO is going to be P1 equal P2, always. HO is always equals. And then H1, it's going to be greater, less, or not equal. It can't be equals because these have to be different, don't they? HO and H1, they're like two attorneys arguing. They can't be saying the same thing or there wouldn't be any debate. Wouldn't need a judge, wouldn't need a jury, right? They're saying different things. This one's saying equal, this one's saying something else. Well, now what is it saying? How do you know if it's greater or less or not equal? Because HO is easy, that's always equals. But how do we know what H1 is? Well, you look up in the words and you see if it ever says more or less or bigger, smaller, higher, lower, something like that. Does it? No, it never really does. All it says is just as likely. What does that mean? That's not equal. Yeah, and that's because here, I'll write it in here again, because it says just as likely. So when it says just as likely, again, that's not equals. Because if I said to you, hey, if you fish with this kind of bait or that kind of bait, you're just as likely to catch fish. What does that mean? Equally likely. Or maybe you're not just as likely. Not equal. So it's an equal, not equal question when they say just as likely. So they might say, well, yeah, but that's equal. Yeah, well, yeah. Then so this one's saying equals. That one's saying just as likely. This one's saying not equal. So not. So he's actually saying it's not just as likely. But the whole question is, are they just as likely or not? So it's equal, not equal. All right. On we go. Now, by the way, what's P1 and P2 in this situation? It's always good to, it's the two groups. P1, and just take them in the order they came. Who came first? Psych majors. So this is the psych people, and P2 is the business majors. And we're saying who's more likely to change their major. Okay. So coming on down, we need to go to the online calculator. We already saw where we're going. It says right there, online calculator to proportions. So let's go there. Oh yeah, let me clear this example. And so here I am, I'm on the calculator. So where is the two proportions? Come on down, it's number 19. See it down there, number 19, two proportions. Click on that. It opens up. Now it wants us to give it, there's what it needs. It needs first sample, second sample, sample size, number of successes. Okay, how do we do all that? Back to it. Oops, wrong way. Here we go. Yeah, so to show you how all that fits in, come up here. So we're going to do the two proportions calculator. And it says sample size, and it says what's the other thing it says? It said a number of successes. Okay, then over here it says first group and second group. Okay. Well, this is a little more tricky this time. So what's the sample size? Well, notice it says 55% of the 640 psych majors change their major. So the sample size there is 640. That's how many people were sampled. And how many, what's the number of successes? Well, that's how many actually changed their major. So that's going to be 0.55 times 640, because it said 55% of 640. And then for the other group, 680 business majors, 55% of them, so it's also 0.55 times 680. Then we're going to have to go to a calculator to find out what those are. So let's go to the online calculator. Oh, and by the way, you see this on the notes. See, it says right here, if given percentages, let's do my highlighter. If given percentages, x1 and x2, like 31% of 490 and 32% of 80, then multiply and round. Multiply and round, because they must be whole numbers, not decimals. All right, anyway, let's go to the calculator. Wrong place there. There we go. There's our problem. So I'm going to go to the calculator. I'm going to put in 0.55 times 640 and 0.55 times 680. Here we go. See at the bottom where it says scientific calculator? Click on that. I'm going to go 0.55 times 640 equals, and 0.55 times 680. Get both those numbers. There it is. You can see them, 352 and 374. 352 and 374. Let's go back. 352, 374. 352, 374. 352, 374. All right, so there's the number of successes, meaning changed their major, out of those sample sizes. So you put those into the calculator, and make sure you also choose the radio buttons. What are the radio buttons we're going to choose? Well, we're going to choose the not equal, because that comes from H1. We have an H1. That's in the notes right here. It says, for hypothesis test, choose greater or less matching H1, and then choose the radio button pooled. I'm going to choose the radio button. Oops, wrong way again. I'm going to choose the radio button next to pooled. Like that. So let's go back and do it. I'm up here. So this is out of 640. This is out of 680. And what were the numbers here? Oh, it's on the 352, 374. So 352, 374, 352, 374. There we go. And now we've got to choose. See the radio buttons over here? We're going to choose not equal. See where I'm messed around? So choose not equal down there. If I can do it, it won't go. There we go, not equal, and choose pooled. See where I'm up here with pooled, no pooled? Choose pooled, and then calculate. And there we go. Now look, our Z is 0 and our P is 1. Our Z is 0 and our P is 1. Let's go back to it. Z is 0, P is 1. Is that what they got? Yeah, they did. See, Z is 0, P is 1. Okay, so now it's time to draw our conclusion. How do we always do that? We put the p-value on one side and the alpha level on the other. That's exactly what's happening right here. It says p-value and alpha. So how do they compare? What's the p-value? With p-value 1.0000 whatever. Alpha is up here. Alpha is 0.1. 0.1. So which one of those is bigger? Well, 1 is bigger than, like this is like $1. This is like 10 cents, right? So the p-value is bigger. Okay, so what's our saying? If the p is low, then the HO, the null, must go, meaning go away. So if the p is low, the null must go. If the p is low, no. So is our p-value low? No, our p-value is greater. So our p-value is most definitely not low. So that means we got to put in a not here and a not there. Is that making sense? The original statement that we memorize. If the P is low, the null must go. If the P is low, the null must go. So if the P is not low, the null must not go away. And that's us, because our p-value is greater right here. This is greater. The p-value, the 1 is greater. Our p-value is not low, it's greater. So if the P is not low, the null must not go away. So if the null, so what does that mean? Now it's time to draw a conclusion. What does that mean? If the null is not going away, then we're failing to reject the null, meaning we're going to keep the null. Is that making sense? Again, if the P is low, the null must go. If the P is not low, the null must not go. Our P is greater. It's not low. So the null must not go away. Don't reject the null. Fail to reject the null. Keep the null. So we see here. Fail to reject. Keep the null. Now, a lot of people say, Mr. N, how do I get these last two? I don't know how to do these last two. Well, that comes from either HO or H1. So let's just go back. I probably should have done this earlier. It doesn't really matter when you do it. But remember, HO is always, let me come up here with the new color. So HO is always weak evidence. And H1 is always strong evidence. Always. H1 is always strong evidence. HO is always weak evidence. Every hypothesis test you'll ever do. It's just like a court of law, right? HO comes first, 0 before 1. What do you do first in a criminal case? You assume the person is innocent. And if the evidence is weak, if there's not strong evidence, you're going to end up sticking with that original assumption. You're going to let the person go, assuming, because evidence is weak, that they're not guilty. But if evidence is strong, you're going to go with H1, and eyewitnesses and things like that, right? So weak evidence versus strong, HO versus H1. So what did we go with? We're keeping HO. We're keeping HO. So you just go up here and go, oh, okay. So it's whatever HO says. So you don't have to think hard about it. It's whatever HO says. What does HO say? Weak evidence, P1 equals P2. So I just write that down. Weak evidence and P1 equals P2, right? That's, well, how'd you get that? It's just what HO says. And how'd you know you wanted HO? Well, right here, if the P is low, the null must go. But if the P is not low, our P was greater, the null must not go away. So in our case, the null is not going away. I'm failing to reject the null. I'm not rejecting the null. I'm keeping the null. If I'm not rejecting it, I'm keeping it. So I went, oh, okay, the null's the one I'm keeping. Let's go up and see what the null has to say, right? I just said, oh, keep the null, okay. What does the null have to say? The null right here, the HO, null is a fancy word for 0. The null says weak evidence. He's always weak. It's not just like court law, you start with weak evidence. And he says P1 equals P2. So I go, oh, okay, evidence is weak, and P1 equals P2. What are P1 and P2 again? Remember, it's the psych majors and the business majors. We're saying that their rate of changing their major is pretty much equal. Equal, right? So our conclusion is the likelihood of freshman psych majors changing their major is equal to the likelihood of freshman business majors changing their major. That's what we think. Why? Well, yeah, see, the percentages came out exactly the same. So yeah, it seems like they're just equal. And so there we go.